We now learn about horizontal translations, and this is another type of function transformation. Now, to illustrate how horizontal translations work, we're going to start with a very well-known function. That's the function whose curve has equation y equals to x squared. Now, we know this function very well. It's the parabola. So if I quickly sketch it here, I have an x and a y axis, like so. And the basic parabola looks something like this. There we go. So that's my curve y equals to x squared. Now, let's say I want to shift this entire curve, say 3 units to the right-hand side. Well, to do that, all we have to do is replace the x we have inside our function's equation by x minus 3. In other words, we'd have to define the new curve whose equation is y equals to x minus 3, in parentheses, squared. Notice that all I'm actually doing is rewriting the curve's equation, but replacing x by x minus 3 in parentheses, where this 3 that's being subtracted from the x is the amount by which I want my curve to move to the right. Now, you can go ahead and check with your graphical calculators, but this new curve, y equals to x minus 3 squared, will be identical in shape to the one we see here, but it will be shifted to the right by 3 units. So starting from 0, that's 1, 2, 3. And it will look something like this. That's y equals to x minus 3 squared. And in a similar way, we could shift this red curve, y equals to x squared, to the left-hand side. For instance, say we wanted to move it 1 unit to the left. Well, to do that, all we need to do is copy the function's original equation, that's y equals to x squared, but we replace x by, in parentheses, x minus negative 1. Negative 1 because we want to move to the left. So that would be y equals to x minus negative 1 squared. And since when we subtract a negative it turns into an addition, this is y equals to x plus 1 squared. And now you can go ahead and check with your graphical calculators, but if we shift this entire red curve 1 unit to the left, its minimum point will now be at negative 1, and the curve itself will be identical in shape to the red one we have here, but it will be shifted to the left. So it will look something like this. That's y equals to x plus 1 squared. Now, luckily for us, what we've just seen for the y equals to x squared function works for any function. And in fact, we can go ahead and write a set of rules. The curve y equals to f of x, that's any function f of x, can be translated horizontally by k units, where k is some number. And there are 2 cases to consider. The first, to the right, by defining the new curve with equation y equals to f of x minus k. Alternatively, it can be moved to the left by k units with the curve with equation y equals to f of x plus k. Do make a note of this rule. It will always work, regardless of how complicated the function gets. Now, we're going to look at some more examples, but before doing so, let me spend a minute just to discuss how to describe translations. Looking back at this first example we had here, y equals to x minus 3 squared, which shifted the curve 3 units to the right, we can use vectors to describe this translation, and we can state the following. Y equals to x minus 3 squared translates y equals to x squared along the vector 3, 0, where this positive 3 tells us that we've moved the curve 3 units to the right, and this 0 tells us that we haven't moved the curve in the vertical direction. And in a similar way, the second example we saw, y equals to x plus 1 squared, well, this translates y equals to x squared along the vector negative 1, 0, where this negative 1 tells us that the curve's been moved 1 unit to the left, and this 0 again tells us that the curve hasn't been moved upwards or downwards. You'll definitely want to pick up the habit of describing translations with vectors. It's very common in exam questions. Okay, now that that's said, let's look at some more examples. Here we're given a curve, and its equation is y equals to x squared minus 3x. And now let's say we need to shift this entire curve 2 units to the right. Well, according to what we've just seen, all we need to do is copy this curve's equation and replace every single x we see by x minus 2. Remember, we're subtracting the 2 here because we want to move to the right. So doing that, the new curve's equation would be y equals to x minus 2 squared minus 3 times x minus 2. All that we've done here is copy the original function's equation, but we've replaced every x we see by x minus 2. And you can go ahead and check with your calculators, but if we plot this new curve, it will look something like this. And we can see quite clearly that this entire curve has been shifted to the right by 2 units. Now we could of course open up these parentheses and simplify as much as possible. And in doing so, we find that this curve's equation is y equals to x squared minus 7x plus 10. So that's the equation of this blue curve here. And we can say that this curve translates the original curve we had, which remember was y equals to x squared minus 3x, along the vector to 0. Let's look at another example. In this case, we're given quite a well-known function. It's the reciprocal function, and its curve has equation y equals to 1 over x. Now, let's say we need to shift this entire curve 3 units to the left. Well, according to what we've seen, to do that, all we need to do is rewrite this function's equation, that's y equals to 1 over x, but we replace the x by x plus 3. Remember, we're adding 3 in this case because we want to move the curve to the left. So that would be the curve with equation y equals to 1 over x plus 3. Now, before sketching this curve, there's something important worth pointing out. The reciprocal function whose curve we see here has both a horizontal asymptote along the x-axis as well as a vertical asymptote along the y-axis. Shifting this entire curve 3 units to the left will also shift its vertical asymptote. Consequently, this new curve's vertical asymptote will have equation x equals to negative 3, and that's the line I'm currently drawing now in green. And the curve itself will be identical in shape to the one we see here, but it will be shifted 3 units to the left, which would look like this. And we can state that the transformation that we've done is a translation along the vector negative 3, 0. Okay, let's look at one last example. Here we're given some function's curve that we see here, and in fact, its equation is the following. Y equals to 0.1 x cubed minus 0.6 x squared plus 0.3 x plus 1. Now, I've purposely chosen this complicated equation to highlight the fact that regardless of how complicated the equation gets, the method for moving the curve horizontally never changes. And so, let's say we need to shift this entire curve 1 unit to the right. Well, according to what we've learned, all we would have to do is replace every x we see inside this function's equation by x minus 1. Remember, we're subtracting the 1 because we want to move the curve to the right. In other words, we need to define the new curve whose equation would be y equals to 0.1 times x minus 1 in parentheses cubed minus 0.6 times x minus 1 in parentheses squared plus 0.3 times x minus 1 in parentheses and plus 1. And remember, all I've done to obtain this equation is copy the original equation we had, but I replaced every x we see by x minus 1. And now you can go ahead and check with your graphical calculators, but plotting this function will look something like this. And we can see quite clearly that all we've done is shifted this curve 1 unit to the right. And we can describe this transformation as a translation along the vector 1, 0. And there we go. That's how to do horizontal translations of functions' curves. And that's it for this tutorial. There we go, everyone. I really hope that helped, and if it did, please hit like on this video and even subscribe to our channel, because that really does help us. I'll see you soon.